All right, we're going to solve radical equations. Now, the whole point of a radical equation is that you have a root. So here we have a square root. And the first thing you want to do is you want to get your square root all by itself, which this one is. Here's the equal sign, and the only thing here is a square root. So once it's all by yourself, you can go ahead and get rid of the square root, which is doing the opposite of square root. We square both sides. Now you have to do it to both sides. Now the square root and the square cancel, and you get x plus 2 equals, and then 7 squared is 49. And then we go ahead and solve. We subtract 2 from both sides, and x equals 47. Now you always want to double check that if you take 47 and plug it in, we can square root that number, which is 49, and you can square root 49, and 49 actually, the square root of 49 actually does equal 7, so this is good. So this is my answer, because when you solve radical equations, you can end up with something called extraneous solutions, which means you got the right answer, but it doesn't still work, so you have to cross it off. Let's look at another example. Okay, so here, notice my square root is not by itself because I have a minus x. So I need to move that x over. So I'm going to add x to both sides. So now I have the square root of 2x plus 7 equals, and then I have 2 plus x. Now, when I square both sides, because now I can square both sides, we have to square the entire side, and you should probably be groaning right now, because what you see is you have a bubble with a plus, and it's being squared, which means I can't distribute the squared. What I have to do is I have to take it times itself, which means a box. On the left-hand side, that one's nice, because we just square root and squared cancel, and we get 2x plus 7. But on the right-hand side, I'm going to have to take a box out, and we get 2 plus x and 2 plus x. You can always rearrange it to be x plus 2, but here I have 2 plus x, so we'll just work with it. And so now on the right-hand side, I have x squared plus 4x plus 4 from what I get inside the box. And now we go ahead and solve this just like you were doing stuff from earlier. So we subtract 2x from both sides, and you subtract 7 from both sides, and we get 0 equals x squared plus 2x minus 3. And then we try and box that out, and we get x squared minus 3. We get x and x. It'd have to be 3 and 1. A positive 3 and negative 1. Would that work? So we get 3x and negative 1x. It does work. So we get x plus 3 and x minus 1 equals 0. Okay, set those equal to 0, and we get x equals negative 3 and x equals 1. Now remember how I told you to check to make sure these things work. So let's try it out. Let's try out the 1. Just because it's easier. If I put a 1 in here, that'll give me 2 times 1, that's 2, plus 7 is 9, and the square root of 9 is 3, minus, and I put in a 1 for x, so 3 minus 1 equals 2. True, very, very true. Okay, so that one works, 1 works. Okay, what if I tried the negative 3? So if I put a negative 3 in here, I get negative 6 plus 7. That gives me 1. The square root of 1 is 1. So then for this right here, I get 1. Minus, and then I plug in negative 3 for x, so it's a negative 3 minus negative 3. So 1 minus negative 3 is 1 plus 3, which gives me 4. And does 4 equal 2? It does not. So negative 3 actually does not work. Just 1 is my answer. So that one has a little bit more involved. But you can do this. This is nothing new. This is all the same kind of math that we're used to. Okay, the other kind of extracting square roots, no, I didn't mean solving radical equations. The other kind is where you don't have the radical there, that root sign. What you have is a fraction as an exponent, which is still a radical equation. And so you're still looking at getting that by itself. Whatever is being raised to this exponent needs to be by itself. This one is. But if I had a plus a number out here or multiplied by a number out here, I'd have to get rid of it first before I could do what I'm going to do. And now I want to get rid of this 2/3, and it's a fraction, and I want it to be 1 now because an exponent of 1 is what I'm looking for. So in order to get that, I need to raise it to the reciprocal. So now it's going to be to the 3/2. And then I do that on the other side to the 3/2. And the nice thing about this is the 3's cancel, the 2's cancel. And so now I just have x minus 4 on the left-hand side. On the right-hand side, let's see, I have the square root of 25. The square root of 25 is 5. And then I cube that. So I have x minus 4 equals 125. I add 4 to both sides, and I get x equals 129. And there's my answer. And of course, you'd want to double check that that works out. And if you go through all the work, you'll see that 129 does work. Okay, so again, if you have a rational exponent like this, you're going to raise it to the reciprocal on both sides and then work through that.